Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video I'm going to talk about real and nominal GDP. In the previous video we defined the GDP as the market value of the goods and services produced within a country in a given period of time. However, comparing GDP across time presents a problem because the prices of goods change as well as the quantities. If GDP grows from one year to the next, it could be because total production increased, but it could also simply be that prices increased. Inflation is a general increase in the price level over time. Because of inflation, GDP typically appears to grow faster than the actual amount that production is growing. To account for this, we are going to calculate the real GDP. To calculate real GDP, we select a fixed point in time to be our base time period, and then we calculate the GDP in all the other years using the prices from that base period. Contrast this with the nominal GDP, which uses the prices in the current year to calculate GDP. We're going to calculate both. For an example, we'll return to the small island country of Santa Maria. Two different goods are produced within this country, rum and bananas. In the table, we have three different years, 2018, 2019, and 2020. And for each year, we have a different price and quantity of rum and bananas. Let's start with calculating the nominal GDP. For the nominal GDP in 2018, we're going to take our rum price times rum quantity plus our banana price times banana quantity. This comes out to 5,250. Moving down to 2019, we can do the same thing, and now we're going to update our rum price to 25, quantity to 250, and update our banana price to 15 and quantity to 300. You can see that across these years, both the price and the quantity are increasing. We get a new nominal GDP of 10,750. Doing the same thing for 2020, we're again going to update all our numbers to reflect the new prices and quantities. And that's going to give us a GDP of 18,375. I'm going to put those numbers in our table. Next, we're going to calculate the real GDP for each year. In order to do that, we need to decide on a base year, and we're going to use the prices from that base year in all of the years. The choice of the base year is arbitrary, and I'm going to pick 2019. So we're going to use the 2019 prices of 25 for rum and 15 for bananas, keep those constant, and then just change the quantities from year to year. So first I'm going to calculate the real GDP in 2018. So we're going to take the rum price of 25 from our base year of 2019, but multiply it by the quantity from 2018 and do the same thing for bananas. 15 is the price in 2019 and 250 is the production in 2018. This is going to give us a real GDP of 8,750. Now for 2019, we're going to use the base year prices again, which also is 2019's prices, but the quantities from 2019 this time. So as you can see, the prices are remaining constant, but the quantities are changing. And the number we get is 10,750. And then finally, we'll do that for our third and final year of 2020. We keep the 25 price of rum the same, but go up to 300 for quantity. Keep the 15 banana price the same, but go up to 375 for quantity. And we end up with 13,125. Note that in the base year, the nominal GDP and the real GDP will be exactly the same, since we are using those prices in all of our real GDP calculations. I'm going to go ahead and put these into our table. Next, we are going to define and calculate the GDP deflator. The GDP deflator in time period T is defined as the nominal GDP in that same time period divided by the real GDP in that time period, multiplied by 100. The GDP deflator gives us a sense for how does the overall price level in year t compare back with the overall price level in the base year. For our example, the GDP deflator in 2018 is going to be nominal GDP of 5,250 divided by the real GDP of 8,750 times 100. If we multiply this whole thing out, we get 60. In 2019, we have a nominal GDP of 10,750 and a real GDP of the same thing times 100, and so we get 100. Since the real GDP and nominal GDP are always the same in the base year, the deflator is always going to be 100. Finally, let's do this for 2020. Here we have a nominal GDP of 18,375 and a real GDP of 13,125. Multiply that by 100 and we get 140. I'll fill those in to our table. If the GDP deflator is above 100, that means the price level is greater in the current year than it was in the base year. If the deflator is less than 100, that means that the overall price level in the current year is lower than in the base year. In our example, we can see that the price level has been increasing year to year because the deflator is going up. To calculate how much the price level is increasing year to year, we can calculate the inflation rate. The inflation rate in year t is defined as the GDP deflator in year t minus the deflator in year t minus 1, so that's last year, divided by the deflator from last year. Multiply that by 100%. So the inflation rate is the percent change in the price level from last year to this year. Let's calculate the inflation rate for our example. We can't calculate an inflation rate for 2018 because we don't know anything about 2017. So we can only do this starting in the second year. So that's 2019. The deflator in 2019 is 100. The deflator in 2018 was 60. And so we take that divided by 60, multiply it by 100%. 100 minus 60 is 40. So 40 divided by 60 is 2/3. And so we get 2/3 of 100%, which is approximately 67% rate of inflation. Doing the same thing for 2020, we take the deflator in 2020 of 140 minus the deflator in 2019 and then divide it by what it originally was there. Multiply it by 100%. Here we get 40 over 100 times 100, which will be 40%. This is just one way of calculating inflation rates. In the next chapter, we are going to look at another one. In our data set here, we have for each quarter, going back to 1947, the nominal GDP and the real GDP. To calculate the GDP deflator, we're going to take the nominal GDP divided by the real GDP and then multiply by 100. I'm going to copy this formula all the way down. The data that we have from the Bureau of Economic Analysis uses 2012 as the base year. Back in the 1940s and 50s, we can see the GDP deflator is far below 100, meaning the price level back then was much lower than it was in 2012. As we move down the data, we can see that the price level is generally rising over time. It doesn't rise every single time period, but in general, it rises over time, and so we say we have inflation. If we keep going down the list, we can see these GDP deflator numbers getting closer and closer to 100. Right here in 2012, which I've highlighted, we can see that the numbers cross over from below 100 to above 100. Since 2012 is the base year and our data is in quarters, you can see that There's no single quarter where the GDP deflator is exactly 100, but it crosses over about halfway through that year. If we were using annual data, then 2012 would have a deflator of exactly 100. Once we get past that year, we can see the GDP deflators continue to rise over 100, meaning that our current price level here in 2020 is about 13% higher than it was back in 2012. If we look at a graph of the nominal and real GDP over time, we can see the nominal GDP rising more quickly than the real GDP, and that's because of inflation. The nominal GDP is below the real GDP up until 2012, where they cross over, and after that, the nominal GDPs are higher than the real GDPs. When we're looking at real GDP, we notice that there is a general trend upward over time, meaning that total production in the United States generally rises over time. That's not always the case, though. We can see a few places where real GDP actually decreases. A period of time where GDP decreases is called a recession. We can see the largest sustained recession since 1947 occurred in 2008 to 2009. This is what we call the Great Recession, which was precipitated by the subprime mortgage crisis. Another striking thing we can see on this graph, of course, is the very right-hand side, where we can see the single largest drop quarter to quarter of the real GDP. This was, of course, caused by the start of the COVID-19 pandemic. In these last two videos, we've covered the basics of calculating and working with GDP data. If you have any questions, feel free to let me know. Thanks for watching.